This is the story of a weapon that cost Nazi Germany close to what the United States spent building the atomic bomb, and killed fewer people in combat than a single night of conventional bombing routinely did elsewhere. This is the V-2, the world's first long-range ballistic missile, built inside a mountain by tens of thousands of enslaved prisoners, and flown into NASA's control rooms by the same engineers who designed it. Michael Neufeld, the Smithsonian's senior curator on the V-2 program, calculated that a minimum of 10,000 people died producing this rocket at its underground factory. The rocket itself, once it reached combat, killed roughly 5,000 Allied civilians and soldiers. Twice as many people died building the V-2 as were ever killed by it. The German army began financing rocket research in late 1932, 2 months before the Nazi Party took power, which places the program's origins before Adolf Hitler ever became chancellor. A young engineer named Wernher von Braun joined that effort at a site called Kummersdorf, working under artillery officer Walter Dornberger, and by December 1934 two early test rockets, designated A-2, had flown successfully from the island of Borkum. The next design in the sequence, the A-3, failed on aerodynamic grounds across 1935 and 1936, and that failure is the direct reason the entire operation relocated to Germany's Baltic coast. Germany's aviation ministry paid 750,000 Reichsmarks in April 1936 for the northern tip of Usedom Island, a location called Peenemünde, and the Army's Rocket Research Center opened there in 1937. The original team, roughly 90 men, moved from Kummersdorf to build something that had never existed before, and establishing Peenemünde cost approximately 300 million Reichsmarks, 100 times what the land itself had cost. By 1942, the site employed close to 5,000 people, with von Braun running the technical side as director while Dornberger remained the program's military head. The V-2's official military designation was Aggregat 4, and it stood fourth in a much longer rocket family Germany's army had been developing since the early 1930s. The A-1, built in 1933, stood 1.4 meters tall, weighed 150 kilograms, and used a small ethanol and liquid oxygen engine designed by a young Arthur Rudolph, the same Rudolph who would later run production at the Mittelwerk. That first rocket exploded on its test stand on December 21, 1933. The redesign that followed, the A-2, flew twice successfully from Borkum a year later. Every launch of the next design, the A-3, tested between 1935 and 1937 to prove guidance technology at a larger scale, ended in failure, and it took a dedicated guidance testbed called the A-5 to finally achieve successful guided flights, starting in October 1939. The lessons from that program fed straight into the A-4, the rocket that would become the V-2. German engineers didn't stop there. They had already sketched an A-9 and A-10, nicknamed together the Amerikarakete, a projected two-stage rocket with a winged upper stage meant to reach transatlantic range, roughly 5,000 kilometers, enough to strike the continental United States directly from Europe. Design work on the A-10 booster began in 1940 under engineer Ludwig Roth, and by December 1941, propulsion engineer Walter Thiel had proposed a clustered engine arrangement generating roughly 1,800 kilonewtons of thrust. Beyond that sat paper designs for an A-11 and an A-12, 3- and 4-stage vehicles that, on paper, could have reached orbit. None of the transatlantic designs ever got fully built, though two modified A-4s with swept wings, designated A-4B, launched from the test site at Blizna as surrogates for the A-9. The first, on December 27, 1944, failed completely, and the second, in January 1945, actually achieved supersonic flight before a wing reportedly failed during the pull-out maneuver. Nobody had built a rocket like this before, which meant nearly every component had to be invented from nothing. The engine needed to produce roughly 25 tons of thrust, fed by a turbopump spinning at 4,000 revolutions per minute that forced a mixture of ethyl alcohol and liquid oxygen into the combustion chamber at 125 liters per second, and that turbopump ran on its own separate propulsion system entirely, steam generated by decomposing hydrogen peroxide through a sodium permanganate catalyst. A second engine bolted onto the first just to keep it fed. Guidance turned out to be the harder problem. A rocket that goes supersonic in roughly 30 seconds and peaks near 80 kilometers of altitude can't be steered by a human hand, so Siemens engineers built a system called the LEV-3 around two free gyroscopes, plus an accelerometer designed by engineer Fritz Müller, an instrument the Germans called the MMIA and which American engineer Charles Starkdraper later renamed the PIGA once he examined it after the war. Helmut Halser built the analog computer, called the Messgerät, that translated the gyroscope's readings into commands for 8 separate control surfaces, for external rudders on the tail fins and 4 graphite vanes sitting directly inside the exhaust jet itself, steered by electrohydraulic servos. A more advanced platform, the SG-66, mounted several accelerometers on a stabilized platform controlled by 3 gyroscopes and included a correction system for crosswind drift. It flew only a handful of times before the war ended, but that design became the direct technical basis for both the American Redstone rocket and the Soviet Scud missile a decade later. Understanding how a rocket survives traveling at 4 times the speed of sound without tearing itself apart required aerodynamic data that didn't exist anywhere on Earth in the 1930s, and that data came out of a supersonic wind tunnel run by physicist Rudolf Hermann, who became the tunnel's director at Peenemünde on April 1, 1937, after von Braun personally recruited him during a visit to Aachen the year before. Hermann built 2 tunnels, one a 20-second blowdown design capable of reaching Mach 4.4, and a second, continuous flow tunnel that held a steady Mach 3.1, and his team had to invent a desiccant system from scratch, because moisture in the air kept freezing into fog wherever it touched components chilled by liquid oxygen, clouding every test. Every fin shape on the finished V-2, every angle on its nose cone, and every placement of every control surface traces directly back to Hermann's wind tunnel numbers. By 1943, his technical staff had grown to roughly 200 people. After the Peenemünde raid, plans accelerated for an even more advanced Mach 10 hypersonic tunnel at a new site called Kakel, and when Hitler ordered German war documents destroyed at the end of the conflict, Hermann personally hid critical components and paperwork rather than comply, material later recovered by an American team led by physicist Fritz Zwicky. Hermann went on to become a U.S. Air Force consultant, a University of Minnesota professor, and eventually the first director of the Research Institute at the University of Alabama in Huntsville, working literally down the road from von Braun's NASA Center for the rest of his career. There's a modern parallel worth sitting with here, and it belongs to consumer electronics rather than aerospace. Getting one machine's control system to correctly interpret and act on a completely separate machine's instrument readings is the exact same interoperability problem that plagues consumer hardware today. The reason USB-C exists at all, because decades of incompatible connectors and mismatched charging protocols caused constant device failures and consumer confusion. Peenemünde's engineers were solving that identical category of problem, getting a gyroscope, an accelerometer, and a command computer to speak one shared language. Except a communication failure in their system didn't mean a phone that wouldn't charge. It meant a 12.5-ton rocket disintegrating mid-flight or landing somewhere it was never supposed to, and that kept happening, over and over, well into 1944. Roughly 1/5 of all operational V-2 launches used a radio beam guidance system called the Lightstrahl, developed by engineers including Helmut Halser, Otto Hirschler, and Otto Hoberg. The system used a defocused Würzburg-Reese radar antenna to project a narrow radio beam the rocket's guidance computer would track during ascent, correcting its course until engine cutoff, and Siemens engineer Friedrich Kirchstein developed the radio motor cutoff mechanism itself. Hitler had actually commented in September 1943 that he was relieved the program had apparently dispensed with radio beam guidance entirely, a statement the historical record shows was simply wrong, since beam guidance stayed in active use for many of the later Antwerp launches. Even with every guidance refinement Peenemünde could throw at it, the V-2 was never a precision weapon. Landing within a 250-meter radius at a range of 250 kilometers meant the rocket's lateral deviation during flight had to stay within 1 part in 1,000, and its engine cutoff velocity had to land within 0.5% of target. Tolerances so tight that even a 1-degree guidance error could spread half of all rockets fired across a band roughly 10 kilometers wide by the time they reached that range. This is the ceiling that no amount of engineering brilliance at Peenemünde was ever going to break through, and it's the single biggest reason the V-2 could terrorize a city but never reliably hit a specific building, bridge, or military target within it. An A-4 rocket flew successfully from Peenemünde for the first time on October 3, 1942, reaching roughly 85 kilometers of altitude and a range close to 118 miles, and Dornberger reportedly told his team they'd just entered a new era of transportation. What Dornberger didn't emphasize afterward, and what the surviving paper trail shows plainly, is that Hitler had already sat through earlier rocket motor demonstrations back in 1939 and come away unimpressed, and that von Braun himself had actually argued against building a mass production plant directly at Peenemünde in the first place. The program's own chief engineer had doubts about scaling the weapon up where it stood, and those doubts would prove justified, just not for the reason he originally worried about. Almost 2 full years passed between that first successful flight and the rocket's actual combat debut. In the meantime, the German war economy kept feeding a program that consumed resources on a scale normally reserved for a nation's most decisive weapons. Historians who've tallied the full cost of Germany's V-weapons program, the V-1 flying bomb and the V-2 combined, land anywhere from roughly $500 million to as much as $3 billion wartime dollars, figures that put German rocketry in the same financial conversation as the American atomic bomb project, whose own cost ran close to $1.9 billion. Stephen Zaloga, writing for Osprey Publishing, priced the V-weapons program at close to $2 billion, nearly identical to the Manhattan Project's total cost. Here's a detail almost entirely absent from popular retellings of the V-2 story. When production rockets began reaching the front in early 1944, they failed at a staggering rate. Roughly 80% of early units either malfunctioned in flight or broke apart before ever reaching their target. Engineers traced the disintegrations to multiple overlapping causes, and the last confirmed fix for the problem didn't reach the assembly line until November 1944, meaning for most of the campaign's active months, a large share of every rocket launched simply failed on its own, with no help from Allied countermeasures at all. Allied ground observers on the receiving end came to recognize a specific signature, a double explosion in the sky, the sound of a rocket breaking apart mid-air before its warhead even detonated on the ground. This failure rate matters enormously to the story that follows, because when SS security officials at the Mittelwerk went looking for someone to blame for defective rockets, they consistently pointed to sabotage by enslaved prisoners. The engineering record tells a different story. Individual sabotage attempts, however real, don't explain the frequency or pattern of the V-2's technical failures. Those were baked into an unfinished, rushed engineering design, not planted there by the people forced to assemble it. On the night of August 17 to 18, 1943, the Royal Air Force launched Operation Hydra, a bombing raid aimed directly at Peenemünde. The raid cost the RAF roughly 40 aircraft and 245 airmen, and it also killed several hundred forced laborers already working at the site, a detail rarely mentioned alongside the raid's more famous strategic consequences. It delayed the V-2 program by roughly 2 months, and far more importantly, it convinced Hitler, Heinrich Himmler, and Armaments Minister Albert Speer that mass production could never again happen above ground, not anywhere the Allies could simply locate and bomb a second time. Speer, SS General Hans Kammler, Dornberger, and armaments officials Gerhard Degenkolb and Karl Sohr met on August 26, 1943, and the decision reached in that single meeting shaped the rest of the V-2's history more than anything that ever happened inside Rudolf Hermann's wind tunnel. Production would move underground, into a mountain called the Kohnstein, near the town of Nordhausen, and the workforce building it wouldn't be paid German civilians. It would be concentration camp prisoners. This is the point in the V-2's story where most retellings quietly change the subject, jumping straight from the bombing raid to the operational launches and skipping over what filled the 18 months in between. That gap isn't a footnote. It's the second thread running through this entire story, and it's the one most space history documentaries leave out completely. The first 107 prisoners transferred from Buchenwald concentration camp arrived at the Kohnstein on August 28, 1943, with another 1,223 following on September 2. They were assigned to a new subcamp called Dora, and their first job wasn't building rockets. It was digging the tunnels the rockets would eventually be assembled inside, and for roughly the first 6 months, prisoners at Dora lived entirely underground with no access to daylight at all. Sanitation amounted to oil barrels serving as latrines. One shift slept in cold, damp tunnels while another shift dug, which meant the tunnels were never empty and never quiet, and typhus, dysentery, and tuberculosis tore through a workforce already worn down by 12-hour shifts, 6 days a week, on rations historians describe as roughly 4 ounces of black bread and a thin soup each day. Management eventually installed a crematorium on site, because the death toll from exhaustion and disease had grown too large to handle any other way. Between October 1943 and March 1944, the first 6 months of tunnel construction, approximately 2,900 of the roughly 17,500 prisoners brought to Dora died there, and another 3,000 who became too sick to work were shipped out to Majdanek and Bergen-Belsen, camps built for extermination rather than labor. By the close of 1943, Dora's work squads had the highest recorded death rate anywhere in the entire Nazi concentration camp system, worse than any other slave labor site in Germany. Dora was never the only camp feeding the middle works labor demand. As production scaled up through 1944, a network of additional subcamps opened around it. Lager Rodelberode, codenamed Heinrich, opened on March 13, 1944, with 200 transferred prisoners. Lager Harzungen, codenamed Hans, opened on April 1, 1944, eventually holding up to 5,000 prisoners. A small camp at Bischofferode, codenamed Anna, opened in April 1944 and closed within weeks, its roughly 300 inmates redistributed elsewhere. And on May 2, 1944, Lager Aurichuliaschut, codenamed Erich, opened inside an abandoned gypsum factory, eventually holding roughly 8,000 prisoners under conditions survivors and historians alike describe as the most brutal in the entire Mittelbau network. The main camp was formally designated Mittelbau on June 8, 1944, with Harzungen and Elrich grouped as Mittelbau 2 and Mittelbau 3, and on October 28, effective November 1, 1944, the entire complex became an independent concentration camp in its own right, no longer administratively subordinate to Buchenwald. On the day of that transition, 32,471 prisoners were counted across the system. By April 1945, the Mittelbau network had grown to somewhere between 39 and 40 subcamps holding more than 40,000 prisoners combined, an industrial slave labor operation on a scale most popular accounts of the V-2 never fully convey. Von Braun's first documented visit to the Mittelwerk, the production facility being carved out of the Kohnstein, happened on January 25, 1944, and he wasn't a distant executive reading reports from a factory he never saw. By his own later admission, he visited the site somewhere between 10 and 15 times over the following year. The Mittelwerk was under contract by late 1943 to deliver 12,000 A4 rockets at roughly 40,000 Reichsmarks each once the assembly line hit full output, and getting a finished rocket out of that mountain and onto a launch site required its own logistics chain. The centerpiece of that chain was a vehicle called the Meilerwagen, a semi-trailer built by the Munich firm FX Mailer, which carried the rocket horizontally to its firing point and then used hydraulic rams, powered by a Volkswagen engine mounted directly on the trailer, to raise the 12.5-ton missile to vertical in under 30 minutes. Roughly 200 Meilerwagens were reportedly built, and only 3 are confirmed to survive today, on display at the Australian War Memorial in Canberra, the RAF Museum in Cosford, and the National Museum of the United States Air Force in Dayton. Fueling followed a strict order for a strict reason. Crews filled the alcohol tank first, a process that took about 10 minutes, and saved liquid oxygen for last, often within the final hour before launch, because liquid oxygen boils off constantly and lingering too long risked icing the valves shut. A full launch column included an armored command half-track, an alcohol tanker, and an oxygen tanker, and the whole sequence from arrival to launch ran roughly 2 hours, after which the crew needed to vanish immediately, before Allied aircraft found them. There's a parallel here that belongs in the world of cybersecurity rather than space history. The Meilerwagen's entire design logic, mobile, fast to erect, fast to fire, fast to disappear, existed because a fixed launch site was a target that could be found and destroyed exactly once. Modern network defense calls this kind of moving, hard-to-pin-down infrastructure a moving target defense, the same underlying idea behind honeypot systems designed to make an attacker waste resources chasing something that won't be in the same place twice. German engineers built that principle into a 45-foot trailer in 1944 out of pure necessity, because Allied bombers had already proven at Peenemünde that anything stationary would eventually get found. But mobility only solved a targeting problem. It never solved the deeper problem with the weapon itself, that speed and stealth can't substitute for accuracy or destructive power, and the V-2's accuracy never got good enough to make it a war-winning weapon no matter how well it hit on the way to the launch pad. By the fall of 1944, the middle work was turning out between 600 and 700 rockets a month, more than 20 a day at its peak between September 1944 and February 1945. And even though that output never reached the 900 per month target the Reich had specified, the total still ran high. Over the life of the program, roughly 6,000 V-2 rockets got built, and the Reich paid close to 450 million Reichsmarks for them, an average cost near 80,000 Reichsmarks per unit before anyone had even added a warhead or guidance system. Somewhere between 5,000 and 6,000 prisoners worked the middlework assembly line at any given moment, with a roughly equal number assigned to harsher construction duty through a separate organization called WIFO, plus another 2,000 to 3,000 German civilian workers and foremen supervising the floor. One of those foremen, Alban Sawatsky, ran day-to-day middlework operations and has been documented personally abusing prisoners. George Rick Hayes served as the middleworks general director from May 1944 onward. Arthur Rudolph, who joined von Braun's rocket team back in 1934 and designed the very first A-1 engine a decade earlier, served as production director, and according to Neufeld's research, Rudolph embraced the SS proposal to use camp labor with real enthusiasm after touring a similar arrangement at another facility. By June 1944, conditions had grown notorious enough that Middleworks' own management issued a confidential decree forbidding German civilian workers from beating or stabbing prisoners with sharp instruments. Read that again. The decree didn't forbid violence against prisoners outright. It forbade one specific method of violence, because that violence had become so routine that management felt the need to regulate it rather than stop it. Roughly 60,000 prisoners passed through the Mittelbau camp system between August 1943 and April 1945, drawn from about 21 nations, and the Mittelbaudora Memorial's official count puts at least 20,000 of them as never having survived, close to 1 in every 3 people sent there. A higher estimate from French historian André Sellier, factoring in deaths during the final evacuation marches in the war's last weeks, puts the total nearer 26,500. Behind the Middleworks civilian managers sat an SS command structure with its own named chain of responsibility. Hans Kammler, the SS Gruppenführer who'd originated the idea of using concentration camp labor for the rocket program in the first place, took formal command of all V-2 operations on August 8, 1944, replacing Dornberger in that role entirely. Otto Forschner served as Doris Commandant until February 1, 1945, when Richard Baer, who'd previously served as the last commandant of Auschwitz, replaced him. Helmut Bischoff, a former Gestapo officer, headed security for the entire weapons program and personally drove the escalation of executions inside the camp during the war's final months, while camp physician Heinrich Schmidt would go on to become the highest-ranking defendant at the post-war Dora trial. Execution numbers at the site weren't small. Roughly 350 prisoners were hanged over the life of the camp, about 200 of them for alleged sabotage, often, historians note, with little proof behind the accusation. After a group of roughly 20 Soviet prisoners attempted a breakout from the Dora bunker on the night of March 9, 1945, 57 Soviet prisoners were hanged 2 days later in retaliation, with 30 more hanged on each of March 21 and March 22, mass executions sometimes staged inside the tunnels themselves, using a crane and beam, specifically to terrorize the remaining workforce. This is where the V-2's story stops being about engineering and becomes a story about complicity, and the record on that point is unusually direct, because von Braun put it in writing himself. On November 12, 1943, he wrote to armaments official Gerhard Degenkolb confirming that Degenkolb had granted permission to employ concentration camp laborers at 2 production sites, and specifying that the ratio of prisoners to German specialists couldn't fall below 2-to-1. 9 months later, on August 15, 1944, von Braun wrote directly to Middlework Operations Chief Alban Sawatsky explaining that he'd personally traveled to Buchenwald, together with a colleague named Dr. Simon, to select additional qualified prisoners for transfer to the Middlework, and that he'd arranged the transfer with the Buchenwald camp commandant himself. That's not a document describing a policy von Braun simply inherited. It's a document describing him personally choosing which enslaved human beings would be sent to build his rocket. Von Braun's own brother, Magnus, also worked at the Mittelwerk, supervising quality control on the rocket's turbopumps from September 1944 onward, which means two members of the same family held supervisory roles inside a facility where a minimum of 10,000 people died. That's not a coincidence. The historical record allows anyone to soften. It's the family running quality assurance on a weapon built by people who were dying at a rate historians describe as the worst anywhere in the entire concentration camp system. Not every documented interaction points the same direction. French physicist Charles Sadran, a prisoner at the Mittelwerk, later wrote in a 1947 memoir that von Braun came to see him personally in the workshop, expressed regret at seeing a French professor in such misery, and offered him a transfer to work in his laboratory instead, an offer Sadran said he bluntly refused. Survivor and author Yves Bion, by contrast, wrote in his memoir Planet Dora that after the war both East and West tracked down the German scientists, in his words, not to punish them but to use them, and that Dora remained what it had been, secret and classified. Neufeld, the Smithsonian's senior curator on this exact subject and the author of the most rigorously sourced biography of von Braun that exists, has spent decades working through this question, and his conclusion lands somewhere between the full exoneration von Braun's post-war defenders offered and the simple villain narrative his harshest critics prefer. Von Braun, in Neufeld's framing, had sleepwalked into a Faustian bargain. He didn't invent the slave labor system at the Mittelwerk, and he had limited power to change conditions once that system existed, but he was present. He recruited from inside Buchenwald personally, and decades later, when questioned under oath in 1969 about what he'd witnessed, he claimed he'd never seen a dead man, a beating, or a killing during his visits to the Mittelwerk, a claim historians treat with open skepticism given everything documented about conditions there during the exact months he was visiting. Not every historian lands in the same spot. Former NASA chief historian Roger Launius has put the tension more bluntly, observing that von Braun spent most of his life building weapons of war, not building rockets to send humans to the moon, a framing that pushes hard against the popular image of von Braun as primarily a space visionary who happened to work under difficult circumstances. Historian Brian Krim, author of Our Germans, goes further still, describing the V-2 as the only weapon to have caused more deaths during its construction than its use, and citing von Braun's own wartime writing that he and his colleagues felt no moral scruples about the possible future use of their brainchild, because they were, in von Braun's own words, interested solely in exploring space. Some of von Braun's defenders, including colleagues, biographers, and family, have argued he was a largely apolitical scientist trapped by forces beyond his control, doing what he could to limit suffering where possible. Historians including Neufeld have noted that certain abuse allegations circulated about von Braun personally may in some cases actually describe incidents involving his brother Magnus, who worked at the Mittelwerk full-time from September 1944 onward, a detail that complicates, without erasing, the paper trail of von Braun's own letters and visits. Here's the number that reframes everything the V-2 usually gets remembered for. Neufeld calculated, in his book The Rocket and the Reich, that a minimum of 10,000 deaths can be attributed to the V-2 program at the Mittelwerk alone. The rocket itself, once it reached combat, killed roughly 5,000 Allied civilians and soldiers across its entire operational campaign. Run that subtraction and the conclusion holds up: roughly twice as many people died building the V-2 as were ever killed by it in combat, and some historians describe it as possibly the only weapon system in history to have caused more deaths through its production than through its actual use against an enemy. Measuring the program's cost against what it actually bought Germany produces an answer that's almost nothing, according to the people who studied it closest. British wartime operational researcher Freeman Dyson, whose job was literally calculating what German weapons were and weren't accomplishing, wrote afterward that a V-2 cost as much to build as a high-performance fighter aircraft, and that the rocket program was doing the Allies almost no military damage at all, close, in his own words, to what would have happened if Hitler had simply chosen to disarm unilaterally. Zaloga's assessment cuts just as sharp. The entire 7-month V-2 missile campaign delivered less total explosive force onto its targeted cities than a single large RAF raid managed to deliver in one night. In a 2019 interview with the National World War II Museum, Neufeld put it plainly: the V-2 was an extraordinarily expensive way to drop a 1-ton bomb on an enemy city, and it came too early, not too late, to be an effective weapon. Picture the trade in modern operational terms. A company that spends its entire annual research budget on a product, only to discover that product delivers less total value than a single day's output from an existing, cheaper process, would call that a catastrophic failure, the kind that gets a division shut down and an executive fired. Germany spent roughly a third of its national fuel alcohol supply, tens of thousands of forced laborers' lives, and an industrial effort comparable to the atomic bomb program on a weapon that Freeman Dyson, the man Britain paid specifically to calculate exactly this kind of thing, concluded was doing next to nothing for the war effort. Hitler ordered the offensive to begin on August 29, 1944, and the first operational launches went out on September 7, aimed at Paris. Both rockets crashed shortly after launch and never reached the city. A single V-2 struck Paris the next morning with modest results, and that evening, at roughly 6:40, the first V-2 to hit London struck Staveley Road in Chiswick. 3 people died instantly: 63-year-old Ada Harrison, 3-year-old Rosemary Clark, and 28-year-old sapper Bernard Browning, and the blast left a crater roughly 30 feet wide and 8 feet deep. Because the rocket traveled faster than sound, residents heard no warning before impact. The explosion arrived first, and the sound of the rocket's descent only caught up afterward. British officials initially blamed a defective gas main, and Londoners started calling the mysterious blasts flying gas pipes, because the government wasn't yet ready to publicly admit an unstoppable rocket weapon now existed. Roughly 1,358 V-2 rockets struck London specifically over the following months, with additional strikes landing on Norwich and Ipswich for a total of 1,402 across Britain, and the deadliest single hit on British soil came on November 25, 1944, when a rocket struck a Woolworths department store on New Cross Road in southeast London around 12:25 in the afternoon, a crowded shopping hour. That single strike killed 168 people and seriously injured another 121. London wasn't even the primary target for most of the campaign. Antwerp was. Roughly half of every V-2 fired during the entire war was aimed at the Belgian port city, because Antwerp's harbour had become the single most critical Allied supply hub in northwestern Europe after its capture in September 1944. The first V-2 hit Antwerp on October 13, 1944, striking Schilderstraat and killing 32 people instantly, while a second rocket hit an abattoir on Lang-Lobroekstraat that same afternoon and killed 14 more. A rocket that landed at Tienersplaats on November 27, 1944, killed another 126 people, including 26 Allied soldiers. The single deadliest V-2 strike of the entire war happened in Antwerp on December 16, 1944. At 3:20 in the afternoon, a rocket fired from Hellendoorn in the Netherlands by an SS unit designated Werfer Battery 500 struck the roof of the Cinema Rex, a theater. Packed with roughly 1,100 people watching a showing of the American film The Plainsman. The strike killed 567 people, including 296 Allied servicemen, and injured another 194 servicemen on top of that, and it remains the largest death toll produced by any single rocket strike of the war. Across the full Antwerp campaign, roughly 1,736 people died in the greater Antwerp area from V-2 strikes, with approximately 4,500 more injured, out of 590 direct hits on the city. Liège, the other major Belgian target, suffered its own devastating toll: 92 soldiers killed and 336 wounded, alongside 1,158 civilian casualties, with 97% of the province's more than 82,000 dwellings damaged or destroyed. A post-war Allied assessment put total V-weapon deaths near 5,000, with around 21,000 injured, concentrated mostly in Antwerp and Liège. Almost no retelling of the V-2 campaign mentions the one detail that actually matters here, which is that the rocket was used against a German target exactly once, and it happened by accident of geography rather than by design. On March 17, 1945, on Hitler's direct order, 11 V-2s were fired at the Ludendorff Bridge in Remagen, a bridge American forces had just captured intact, opening a crossing point straight into Germany. The launch sites originally aimed at Antwerp couldn't be re-aimed precisely enough in time, and the closest rocket landed 270 meters from the bridge, while a stray hit struck a nearby and serving as an American engineering company's command post, killing 3 soldiers. The bridge itself collapsed later that day, but from accumulated combat damage and heavy traffic, not from the rocket strikes. Even in the one case where the V-2 was aimed at a genuine military target instead of a city full of civilians, it missed. British intelligence had been working to understand and counter the rocket threat well before the middlework finished construction. Duncan Sandys, Winston Churchill's son-in-law, chaired the government committee responsible for tracking Germany's rocket program, and scientific intelligence officer R.V. Jones led the analytical work piecing together what the weapon actually was, aided by aerial reconnaissance photographs of Peenemünde interpreted in part by Royal Air Force photo analyst Constance Babington-Smith. British intelligence also drew on resistance networks across occupied Europe. The Polish Home Army recovered a crashed test rocket near Blizna and smuggled components back to Britain in an operation called MOS 3 on May 30, 1944, and a separate rocket that malfunctioned and landed in Sweden on June 13, 1944, gave analysts another intact specimen to study. Both recoveries fed directly into Britain's understanding of the rocket's true capabilities, eventually confirming its warhead was far smaller than some early assessments had feared, roughly 1 ton of explosive rather than the multi-ton payload some analysts had originally guessed at. That intelligence effort mirrors something modern security teams would recognize instantly. Analysts spent enormous resources reverse engineering a weapon from crash debris and photographs, doing exactly what a modern cybersecurity team would call threat intelligence gathering, reconstructing an adversary's capability from fragments before the adversary ever fully deployed it. And the conclusion British intelligence eventually reached mirrors exactly what German records show internally: the V-2 was less capable, and mattered far less strategically, than either side's early fears suggested. That conclusion feeds directly into a genuine historiographical debate. If the V-2 really was this militarily marginal, was the Allied countermeasure effort itself a good use of resources? At points during the campaign, the British government demanded that up to 40% of available bomber sorties be diverted toward hunting launch sites, and every sortie redirected that way was a sortie not flown against German industry elsewhere. Operation Hydro alone cost 40 aircraft and 245 airmen and only delayed the program by roughly 2 months. Some historians argue that once the V-2's true ineffectiveness became clear, the diversion of Allied resources to chase it down amounted to a major success for Hitler in its own right, a weapon so bad at its intended job that merely defending against it still cost the Allies real resources anyway. The campaign ended abruptly rather than gradually. The final 2 rockets to strike Britain landed on March 27, 1945, and the last British civilian killed by enemy action in the entire war, 34-year-old Ivy Millichamp, died in that final strike at Orpington in Kent. Germany's ability to keep launching rockets simply collapsed alongside the rest of the war effort. Launch sites were being overrun, transportation networks were disintegrating, and the underground factory that had built the weapon was about to fall into Allied hands. American forces from the 3rd Armored Division and the 104th Infantry Division liberated Dora and the Middlework on April 11, 1945. And what they found matched the death rate statistics that had defined the camp since 1943, roughly 3,000 corpses and only around 750 survivors still on site, the rest having already died, been transferred elsewhere, or been forced onto evacuation marches in the war's final chaotic weeks, marches that killed thousands more on their own. One of those marches ended in the Gardelegen massacre in early April 1945, when approximately 1,016 prisoners evacuated from Middelbau and a related camp got locked inside a barn that was then set on fire, and only 20 to 25 people survived. Von Braun didn't wait to be captured at the factory he'd helped staff. On May 2, 1945, he and his engineering group surrendered to the American 44th Infantry Division at Riad in Austria, with his brother Magnus reportedly making first contact with American forces by bicycle. SS General Hans Kammler, the man who'd originated the idea of using concentration camp labor for the rocket program in the first place, disappeared entirely in May 1945 and was never conclusively accounted for, though declassified document research published in 2014 has raised the possibility he may have been captured and quietly interrogated by American intelligence rather than dying at the war's end, as long assumed. Here's the contrarian angle at the center of this entire story, and it isn't a matter of opinion. It's documented American government policy that got deliberately circumvented. President Harry Truman's directive on recruiting former enemy scientists explicitly barred bringing in active Nazis, and American intelligence officers running what became Operation Paperclip got around that directive by rewriting the scientists' own records. One security report on von Braun originally labeled him a security threat, and by the time that same file passed through the recruitment pipeline, it had been softened to describe him merely as a man who may have been an SS officer, a rank he'd actually held, reaching the level of Sturmbannführer, or Major. The program's informal name came from the literal paperclips attached to the files of scientists whose Nazi-era records were considered troublesome enough to need special handling. Colonel Holger Toftoy of the U.S. Army Ordnance Branch organized the recruitment effort on the ground. JIOA Director Boskidwev pushed dossiers through over the objections of State Department Representative Samuel Klaus, who initially flagged several of the scientists as ardent Nazis and had their visas denied before the policy got overridden. Von Braun and roughly 1,600 other German specialists relocated to the United States, with von Braun himself sent toward Fort Bliss, Texas, on a formal transfer order dated June 20, 1945. Truman formally approved the broader paperclip program in September 1946. The team transferred to Redstone Arsenal in Huntsville, Alabama, by 1950, and von Braun and his colleagues became naturalized United States citizens in 1955. What followed is one of the most complete image rebuilds in 20th century history. A man who'd worn an SS officer's uniform and personally selected concentration camp prisoners for a weapons production line became, in the American press and eventually in American government service, a visionary of peaceful space exploration. A rocket descended from his team's work launched Explorer 1, America's first satellite, on January 31, 1958. Von Braun became the first director of NASA's Marshall Space Flight Center on July 1, 1960, and on July 16, 1969, the Saturn V rocket, engineered under his direction and built on technical lineage running directly back through the guidance systems and engine designs first proven at Peenemünde, launched Apollo 11 toward the Moon. Sit with that reframe for a second. The same engineering team, the same underlying rocket technology, and in some cases the exact same individual engineers who built a weapon responsible for a minimum of 10,000 slave labor deaths were, within roughly a decade, standing in NASA control rooms being celebrated as the architects of humanity's greatest peaceful achievement. That's not a footnote to the space program's origin story. It is the space program's origin story, minus the part almost every retelling leaves out. Von Braun wasn't the only Peenemünde veteran to make that same journey either. Engineer Kurt D. Buss, a former Nazi Party member with his own SS affiliations, went on to become the first director of NASA's Kennedy Space Center, the launch complex that sent Apollo 11 to the Moon. Almost none of the people responsible for the Middleworks death toll ever faced meaningful consequences. George Rickhay, the Middleworks general director, stood trial at a 1947 war crimes proceeding in Dachau commonly called the Dora trial and walked away acquitted, because the trial's scope stayed narrowly focused on individual acts of cruelty rather than systemic responsibility for the production system as a whole. Of the 19 defendants tried, 15 were convicted, but only one, camp leader Hans Moser, was executed. Arthur Rudolph, the operations director who'd embraced slave labor with such enthusiasm back in 1943, was never even charged in the immediate post-war period. Instead, Paperclip recruited him alongside von Braun, and he eventually became NASA's project director for the Saturn V, the same machine that carried American astronauts to the Moon, and in 1969 he received NASA's Distinguished Service Medal for that work. That changed in 1979, when Justice Department investigator Eli Rosenbaum, working for the newly created Office of Special Investigations, learned of Rudolph's wartime role through a book documenting the transport of rocket parts using forced labor. The investigation that followed led Rudolph to sign an agreement on November 28, 1983, and in 1984 he formally renounced his American citizenship and left for West Germany rather than face further proceedings. Nobody ever prosecuted him criminally, and his American pension and Social Security benefits stayed intact. West Germany ran its own independent investigation and also declined to prosecute, citing the statute of limitations on everything short of murder, and eventually restored his German citizenship. Rudolf died in Hamburg in 1996, having faced accountability only in the narrow form of losing citizenship in the same country that had, decades earlier, deliberately rewritten his file to bring him in. Between roughly 12,000 and 20,000 people died producing the V-2 under a system Arthur Rudolph personally ran, far more than the rocket itself ever killed in combat, and Rudolph's post-war consequence amounted to expulsion rather than prosecution from the very country that had spent decades honoring him for building the Saturn V. For most of von Braun's American career, his SS membership and his documented role at the Mittelwerk stayed largely absent from his public image. He died on June 16, 1977, in Alexandria, Virginia, still widely regarded in American culture primarily as the father of the Saturn V and the man who made the moon landing possible. It took a formal declassification of roughly 8.5 million pages of previously secret records in 1998, following directly from the Rudolph case and journalist Linda Hunt's reporting, before the full extent of von Braun's SS record and his personal involvement at the Mittelwerk became fully accessible to historians and the public alike. The institutional reckoning came even later, and it came from the very institution von Braun helped build. In 2021, the U.S. Space and Rocket Center in Huntsville, a Smithsonian affiliate, removed a bust of von Braun from display days after a journalistic inquiry raised questions about the honor, and later took down a quotation attributed to him describing rockets as freeing humanity from what he called the chains of gravity. NASA renamed a conference facility in 2023 that had honored Kurt Debus and updated his official biography to explicitly mention his Nazi-era history. NASA's own biography of von Braun today includes direct acknowledgement of both his slave labor connections and his Nazi Party and SS membership, and NASA chief historian Brian Odom described the institution's current position in 2023 as recognizing what he called the difficult duality of von Braun's contributions to the space program alongside his association with the Nazi Party. And yet the V-2 did accomplish something, just not the thing it was built to do. A single test flight designated MW18014 became the first human-made object to cross the boundary of space on June 20, 1944. After the war, American teams launched 67 refurbished V-2s from White Sands, New Mexico, between 1946 and 1952, carrying instruments that captured the first photographs of Earth taken from space on a flight on October 24, 1946, and, on a February 20, 1947 flight, fruit flies that became some of the first living organisms to survive a trip to the edge of the atmosphere. The Soviet Union, for its part, launched 11 captured V-2s of its own in 1947, at least one returning usable cosmic ray data from onboard instrument packages. A combined American rocket program called Bumper, pairing a V-2 first stage with a smaller WAC Corporal upper stage, achieved its breakthrough on February 24, 1949, when Bumper 5 set a new altitude and speed record, its upper stage reaching roughly 5,150 miles per hour, more than double the V-2's own previous record, and briefly the fastest human-made object ever flown. In July 1950, Bumpers 7 and 8 carried out the first launches ever conducted from Cape Canaveral, the same launch site that would later send astronauts to the moon. The rocket that failed to win Germany the war became, within less than a decade, the technological foundation for the entire American and Soviet space programs, and the same guidance principles proven in Rudolf Hermann's wind tunnel and Fritz Muller's accelerometer would eventually steer the Redstone rocket that carried the first American astronaut into space, and the Saturn V that carried Americans all the way to the moon. The site where the V-2 was actually built carries its own separate, ongoing history of remembrance. A memorial has stood at the former Dora camp since the 1960s, and the underground tunnel section reopened to visitors in 1995, 50 years after liberation. A new museum building opened at the site in 2006 and won a National German Museum prize 2 years later, and the memorial's standard figures still match the wider historical record. Roughly 60,000 prisoners passed through the camp system, at least 20,000 of them died, and the death rate worked out to close to 1 in every 3 people sent there. The site runs active educational programming into the present, including guided tours led by trained staff and an international study camp for students that met again as recently as the summer of 2025, and on April 11, 2025, the memorial marked the 80th anniversary of Dora's liberation with a formal commemoration, honoring both the survivors who lived through the camp and the tens of thousands who never made it out. Return, now, to the number this whole story opened with. Roughly 5,000 people died from V-2 strikes across the entire operational campaign, while a minimum of 10,000, and by some estimates closer to 20,000 or more, died just building the weapon in the first place. The program cost somewhere between $500 million and $2 billion wartime dollars, and effort historians consistently compare to the Manhattan Project, and Neufeld's blunt assessment stands as close to a final verdict as this story gets. The V-2 was an extraordinarily expensive way to drop a 1-ton bomb on an enemy city, and it arrived too early, not too late, to ever become a genuinely effective weapon of war. Most popular retellings remember the V-2 as the birth of the space age, a triumphant origin story for humanity's reach beyond Earth, and that story isn't false. It's simply incomplete. The rocket that opened the space age was also history's clearest example of a weapons program that failed on its own terms, built inside a mountain by people who were worked and starved to death faster than the weapon itself ever killed anyone on the other side, engineered in large part by men who were, within a decade, wearing NASA badges instead of SS ones. So the real question isn't whether the V-2 changed history. It clearly did. The real question is which version of that change gets remembered, the rocket that reached space, or the mountain, and the 20,000 people it took to get there.